Section 37 is entitled Solving Equations with Fractions. If you have a number, I'm looking for a number that if you divide it by 6, and then you divide the number by 5, and then you add them up, you get 10. I'm looking for a number. If you divide it by 6, write down that answer, divide it by 5, write down that answer, add them up, you get 10. Okay, that's the number I'm looking for. Oh, what you do is you have x over 6 plus x over 5 equals 10. Now, you want to get rid of the fractions. You want to get rid of the denominators. The least common multiple of the two denominators is 30. I mean, 5 is just 5, and 30 is 5 times 6, where 6 is 3 times 2. So it's 5 times 3 times 2. The different bases I see are 5, 3, and 2. So the LCM will have 5 3s and 2s in them. 5 3s and 2s. I'm looking here and I'm looking here. The largest power of 5 that I see, well, I see 1 and 1. The largest power is 1. I won't even put the 1 there. Between 3, there's no power is 3 here. Power of 3 is 1. Yeah, 3 to the 1 wins. 2 and no 2s. The largest power of 2 I see is 1. I won't write the 1. And when you multiply those three numbers, well, you get 30. So the LCM is 30. Or you write down the 5 times table, you write down the 6 times table, and you look for a common number. So I'm going to denote that I'm multiplying each term by 30. And we're picking 30 for one reason. The denominators going to 30. So I get 5x. A lot of students will write 30x over 6. These students don't understand why we're multiplying by 30. Excuse me. We're multiplying by 30 to get rid of the denominators. So we just have 5 times x, which is 5x, plus x times 6, which is the same as 6 times x, is equal to 10 times 30, which is 300. 1 times 3 is 3. Don't forget to add 2 zeros. There they go. So 11x's is 300. We have a product. Here's our answer. Take the answer, divide it, say, by 11, and get the other number, x. That is the number. If you take this number, if you take 300 over 11, and you divide it by 6, and then you take 300 over 11, and now divide it by 5. If you add them up, if we didn't make a silly mistake, and I don't think we did, you'll get 10. Do the arithmetic. This number becomes 300 over 66, plus this number, when I divide it by 5, becomes 300 over 55. And I want 10. So I can reduce these, I guess. 3 goes in here 22 times, and 3 goes in here 100 times. And you know what? Actually, I should have said 6. And 2 goes in here 11 times, and 2 goes in there 50 times. And 11 goes in here, 5 goes in here 11 times, and 5 goes in here 60 times. So I get, so the bottoms are now the same, and I get 50 plus 60 on top, which is 110, and that's 10. 11 times 10 is 110. So we did check. Math would be more fun if you understood what you're doing. You're looking for a number that if you divided by 5 or divided by 6 and add up those two results, you get 10. It's not just boring, dry stuff. You have 2 divided by x squared plus 1 over x equals to 1. Believe it or not, this is a quadratic equation, because the LCM of the two denominators of x squared and x will be x squared. If I multiply this one by x squared, the x squares cancel out, providing x is not 0. 0 squared over 0 squared, namely 0 over 0 is not 1. And if I multiply this by x squared, and I multiply this by x squared, well, you get 1 times 2, provided x is not 0. Over here, 1x in the bottom kills off one of the 2 x's on the top. So you only have 1 left, provided x is not 0, which I already wrote down. And you have plus 1 times x is equal to 1 times x squared. So the right side has x squared, so I will move the x squared. If the plus x, I have to move to the other side is minus x. And the understood plus 2, I move to the other side is minus 2. And if I move everything to the other side, the left side must be 0. So now I can factor the right side. Since it's x squared, it's the x followed by number game times x followed by number game. And here's an understood minus 1. I would love 2 numbers that multiply out to negative 2, but add up to negative 1. And the 2 numbers are negative 2 and positive 1. So either this is 0 or that's 0. This is 0 when x is 2. That is 0 when x is negative 1. I have to reject any of these numbers that I can't allow to have as an answer. Okay? I have to reject 0. But then again, we never got 0 as an answer. So the answer is x is 2 or negative 1. We can check 2 divided by x squared plus 1 over x should equal 1. Well, if x is 2, this is 2 over 4, which is a half. Plus a half, that equals 1. If we try negative 1, we have 2 over x squared plus 1 over x, which is negative 1. Excuse me. Does this equal 2, 1? Well, here you have 2 over 1, which is 2, plus 1 over negative 1 is negative 1. And 2 plus negative 1 is 2 minus 1. And the question is, does it equal 1? Well, of course 2 minus 1 equals 1. So we checked. Let's try a couple more of these. Suppose you have 5 over 2x minus 1 is equal to x over 6 plus, say, 4 over 3. Remember, 6 is 3 times 2. So I didn't write down this factor on the bottom, so that must be in their LCM. I didn't write down 3 first. You put numbers in the front. I didn't write down 2 first. It's the 2 in the front. And I did write down the 3. After all, there it is. And 3 times 2 is 6. So this here is the LCM. So I'm going to denote that I'm taking each term. I'm taking the first term, and I am multiplying it by 6 times 2x minus 1. And this is going to equal to the second term, times 6 times 2x minus 1 plus, now I'm going to take the third term, 4/3, and denote that I'm multiplying it by 6 times 2x minus 1. And I get what I get. The 2x minus 1's cancel out. And I'm left with 5 times 6, or 30. But they don't always cancel out. They don't always cancel out. If 2x minus 1 is 0, we have a problem. If what I just circled is 1, we have a problem. 1 minus 1 is 0. So 2x equals 1, that's the problem. Divide by 2, you get x is equal to a half. We will not allow that. Equals. Now the 6's, they do cancel. The 6's, they really do cancel out to 1, and you're left with x times 2x minus 1, which is 2x squared minus x, plus 3 does go into 6 2 times. 4 times 2 is 8. Distribute the 8. You get 16x minus 8. And then you take away 30 from both sides, come underneath the numbers. The left side is 0, the right side is 2x squared, minus 1x plus 16x's is plus 15x's minus 38. Now, assuming we didn't make any mistake, we're going to have to solve this by grouping. Because although I can divide this by 2 and this by 2 and even the 0 by 2, I can't divide that by 2. So we multiply. We multiply. And after multiplying, we get negative 76. Now on two numbers, they multiply out to negative 76. But add up to a fairly large number like 15. Well, you can try 76 and 1, negative 1. They multiply out to negative 76, but they add up to 75. You can try 38 and negative 2. You can try negative 4 and 19. And there's the ticket. But I'm going to write the negative 4 first, the negative number first, and the 19 second. Okay. Then I'm going to try to come up here. So I rewrite down this line, that instead of plus 15x's, negative 4x plus 19x's. So we have 2x squared minus 4x, we group that, plus 19x's minus 38. And we group the last two. From the first bracket, I can pull out a 2x. So I'm left with x minus 2. Plus the second bracket, I can pull out a 19. And I'm left with x minus 2. And x minus 2 is common. So I have x minus 2 times 2x plus 19. So though I haven't been writing it, this mess is equaling to 0. The two lines above should have said that. Okay, do the space. I'm going to erase the next line. So either x minus 2 equals 0, which means x is 2, or 2x plus 19 is 0. Bring that over. That means 2x is negative 19. Divided by 2, we get negative 19 over 2. X is 2, or x, the possible answers are x is 2, or x is negative 19 over 2. So we can't allow a half to be an answer. Or we're not. Whoever said a half is the answer. If 2, if that would have been a half instead, I would have rejected that answer, and the answer would only be negative 19 over 2. And that is how you do that problem. And let's try one more. be 1. X is 1. So if you have x over x plus 1, well, this is 1 over 2. The left side is a half. And just make the right side also equal to a half. Suppose you have 3x plus 4. Well, this top number when x is 1 will be 7. So you want the bottom to be 14. You can say 10x's, which are 10, and then coincidentally add 4 as well. And you'll have 7 over 14, which is a half. And now we're going to solve this problem. The LCM is, well, it should be a drop capital. Possibly after we factor the 10x plus 4, maybe it will be, after we factor out the 2, maybe it'll be 2 times x plus 1. But it wasn't. So we need to write down the x plus 1. It's x plus 1. We need to write down the 2. And if this was also x plus 1, we wouldn't have to write it down again. And this would have been our LCM. But it's 5x plus 2, and we must write it down. So we have x over x plus 1. This is equal to 3x plus 4 over 2 times 5x plus 2. And we're going to multiply both sides by our LCM. 2 times x plus 1 times 5x plus 2. 2 times x plus 1 times 5x plus 2. And the x plus 1's cancel, but only if x is not negative 1. Negative 1 plus 1 is 0. So we're left with here 2x times 5x plus 2. 2x times 5x, why that's 10x squared, and 2x times positive 2 is positive 4x equal. Here, you have the 2's canceling the 1. Always. 2 over 2 is always 1. So 5x plus 2 over 5x plus 2 is not always 1. Not when the 5x plus 2 equals 0. Not when the 5x is negative 2. Divide by 5, you get x is negative 2 over 5. We will not allow that. We will not allow x to be negative 1 nor negative 2 over 5. And what we're left with on the right side is this product. This times this. 3x times x is 3x squared plus 3x plus 4 more x's is 7x's plus 4. So that's where we are right now. Since there's more x squared on the left side, I'm going to bring all the x's to the left. I'm going to bring everything to the left side. I'm going to take away 3x squared. I'm going to take away the 7x's. I'm going to take away the 4. By design, the right side is 0. The left side, take away 3x squared. I take away 7x's. I take away 4. I'm going to have 7x squared minus 3x's minus 4. Now that's the equation I have to factor. Top right. 7x squared minus 3x minus 4 is 0. I multiply those two numbers. I get negative 28. Now I want two other numbers that multiply out to negative 28 but add up to negative 3. And since the product is negative 28, I know the signs will be different. I'm definitely going to let the second number be positive. And how about negative 7 and 4? How about negative 7 and 4? They multiply out to negative 28, and they even add up to negative 3. It looks like a charm. So let's continue with factoring by grouping. So the 7x squared doesn't change on top. But the minus 3x, we're going to write it down this way. And the minus 4 doesn't change. remember the first two and the last two. And by design, we made sure the middle was plus. In the first bracket, I can factor out a 7x. And I get 7x times x is 7x squared minus, and 7x times 1 is 7x plus. Now when I factor out a 4, 4 times x is 4x, and positive 4 times negative 1 is negative 4. Then I factor the whole thing. X minus 1 is common, and then I have 7x plus 4 left over. This is 0. So either x minus 1 is 0, and we all know 1 minus 1 is 0, so x can be 1, and that's what we started with. And then right to the second answer. 7x plus 4 can be 0. That means 7x can be negative 4. Negative 4 plus 4 is 0. 7x can be negative 4. Divide by 7. You get x equals negative 4 over 7. These, for the moment, are the two possible answers. We cannot allow negative 1 to be an answer, and we're not. And we're not trying to. And we can't allow negative 2/5 to be an answer. But we're not. So the answer is x is 1 or negative 4 over 7. Okay, on that note, this completes the section on solving equations with fractions. Good luck with it.